So here's another problem which is often asked for roles such as quant analyst, and it tests your understanding of total probability theorem, which is something fairly fundamental and you should be aware of if you're preparing for uh, interviews for roles in quantitative finance. So let's take a look at this problem. There is one amoeba in a pond. After every minute, the amoeba may die, stay the same, split into two, split into three, each with an equal probability, which is 1/4. All offspring behave independently in the same way. Find the probability that the entire population eventually dies out. So what's the problem saying? So we have a pond here. There is one amoeba. After every minute, this amoeba will go into one of these four states. So let's say it splits into three. Sorry, split into two. So we have two amoebas after first minute. Then each of these amoebas will behave the same as the previous one. It could stay the same, die, split into two or three. So let's say this one splits into three, whereas this one dies out. Then we have three amoebas here. And the same process will repeat over and over again. And we have to find what's the probability that the entire population dies out. So let's see how we can approach this problem. So let's define an event E, which is the event of extinction of amoeba. So what we need to find is P of E, which is the probability of this event E. Now, whenever you have to find such a probability and you are given a set of different conditions, always think about the total probability theorem, which we can write as probability of an event E is equal to P of E given some condition C1 times probability of C1 plus probability of event E given some condition C2 times probability of C2 and so on. So now let's say this probability which we have to find, we'll call it P, small p. And C1, C2, C3, C4 are these conditions. So what does this become? So the total probability of extinction, which we are denoting as small p, is equal to probability of extinction given that C1 has happened, which means the amoeba dies immediately. So if the amoeba dies immediately, the extinction probability is 1 because obviously there's one amoeba to begin with. If it dies out, it's extinct. Times the probability of C1. So what's the probability that it dies out immediately? We are given the problem. It's 1/4. Plus, what's the probability of extinction given that C2 happens? Which means it stays the same. So if it stays the same, the probability is the same as it was in the beginning because we started with a single amoeba and it stays the same. So we still have a single amoeba and the probability is what we saw. We are denoting with a small p. So small p times probability of C2, which is 1/4 again, plus similarly expanding this into the third condition that it splits into three. So what's the probability? I'm sorry, it splits into two. What's the probability of extinction? If it splits into two, we'll have two different amoeba. Each of them behave independently. So the probability of extinction would be P times P. And what's the probability of this third condition? That it splits into two, 1/4. And then the last case, it splits into three. Similar case. So we have P times P times P times 1/4. So we've got an equation in P, and this is what we'll have to solve to find the answer. So let's see. So as we saw in the previous slide, we assumed P is the probability of extinction. Each minute, the amoeba can either die out, stay the same, split into three. Each of these cases happen with a probability of 1/4. So as we saw from total probability theorem, we can write P as a sum of these conditional probabilities. So the total probability of extinction equals 1/4, which was coming from this first case that it dies immediately. It stays the same. This gave us the second term, splits into two. This gave us this term, splits into three. This gave us this third cubic term. So we have a cubic equation in P, and we need to solve this to find the answer. So we multiply both sides by 4, bring all terms on one side, we get this equation. We need to find the roots of this equation to find the probability. Solving for the roots of this equation, we find that there are three roots: 1, -1 plus root 2, -1 minus root 2. So this is negative. We reject this, probably cannot be negative. This is 100% probability. So we take the non-minimal solution, which is the second root, -1 plus root 2, and this is the final answer to this question. Thanks for watching. Don't forget to subscribe on YouTube. Also sign up on datalooper.com. See you in the next video.